So we are now broadcasting. I'm showing your All right. Good evening, everybody. Welcome to yet another TWed of the spring 2017 term. Just a few logistical notes. Number one, if you haven't already, sign up for the TWed lightning talks at the end of the term. Some of you have signed up. Everybody is well, actually, you are strongly encouraged by all of your research advisors to sign up. Does anybody not know what a TWed is? A TWed lightning talk? Shut up. TWed, just as just a quick reminder, TWed lightning talks are 2-minute talks without notes summarizing your research, and we have everybody in TWedless, everybody in Winslow down here talking through it at the end of the term, and it's awesome. It's a lot of fun, and it's the best way to get a summary of what research is going on in TWedless world. Remember that we are streaming this live and recording it, so feel free to ask questions during Katie's talk, but also keep in mind that it's going out on the interwebs. Katie Chastain is one of our longtime, not quite tenured grad students, and she's going to give kind of a quickie intro to SETLr, the tool that she's been using for semantification, but spend more time talking about semantifying data dictionaries and all that awesome work. So without further ado, take it away, Katie.
Okay, thank you. Hi, I'm Katie Chastain, grad student under Professor McGinnis, and I've been working with semantic data ingestion for cool semantic web tools. Right now, my research is with the Gates Foundation Healthy Birth, Growth, and Development project, so lots of child health data. So I'm going to talk about semantic data dictionaries and how we're using them to sort of bring more data into cool semantic web visualization tools. So I'm going to go over some of the motivation for having an easier process by which to bring data into tools like this. I'm going to talk a little bit about SETLr for data conversion, and also data dictionaries, extending them for better semantic use, filling in the gaps in that pipeline, which is sort of what I'm working on right now, and maybe some possible directions for some future work. So for linked data, a lot of our applications, we have sort of a data pipeline that looks like this. We have our legacy tabular data from a variety of sources. We have ontologies, either that we locate, that we build, that we extend here in the TWedless world. Something happens and we have data, linked data in cool front-end visualizations, search tools, endpoints. Step 3 is sort of something that we've been working on, and we have some good solutions within the lab, but we're also looking at ways to make that sort of conversion process, making data ready for semantic web tools, more accessible to domain scientists. And that step is not an easy one. We have to do at least usually semantic annotation, tagging the entity types with semantic types. At most, we have to do complete conversion into something like Turtle or RDF. It requires domain knowledge as well as ontology knowledge. And right now, our processes involve a lot of handcrafted parameters files as well. And so for ingestion of large amounts of legacy data, we need something that's maybe a little bit more scalable. And it's because another reason it's complicated is because tabular data in like your CSV files is it's conceptually different in a structure than the graph-based data that we work with in our linked data applications. And this is a problem that's been in computer science for a long time, since we've had, it became more prominent with object-oriented programming, when we're sort of trying to get the object-oriented structures, pulling data for those into from relational databases. And with the semantic web, we like to focus a lot on relationship types in particular, in addition to the entity types, and that sort of adds like a whole new dimension to this problem. And so there's been work ongoing for some time as well. Extraction of that implicit structure of the data that lives inside those files, we sort of have to simplify it in a way that's convenient for us to sort of fit it into that spreadsheet structure. And we call that database reverse engineering, is sort of the idea of like picking out that structure from a tabular data file. And that's fairly easy for human users to do. But as far as doing it programmatically, relational algebra and set theory have provided methods and algorithms to sort of do that automatically. But there's still a lot of work to go on that. The relationships in particular are difficult. A lot of the earlier algorithmic methods focus on sort of the entity types without really addressing the entities much, if at all, or with the relationships rather, much, if at all. Some more recent developments in things such as crowdsourcing and natural language processing has helped with also just having lots of data available, particularly on the web with semi-structured and structured like web tables and stuff like that has helped improve methods for improved methods for identifying and extracting those relationships, but it's still not quite there yet. And one aspect of this is the foreign key relationship in relational databases. And so the good news is that if you have a foreign key relationship, then you can be pretty sure that there's some sort of relationship between entities going on between those tables in your relational database. But the bad news is that we've kind of overloaded this relational database construct. And this particular study, Cleve and Hineout in 2012 identified about a dozen different possible things that people can mean in terms of the nuance of the relationship when they're using a foreign key in a relational database. So to sort of change gear a little bit, one of the tools that we've got for converting semantic data or data into linked data is SETLr. Jim McCusker has developed and has been working on it. It's ongoing, and this is the GitHub link here. I'll upload these slides after I reskin them with the Tetherless World slide deck. And SETLr is based on Python and JSON LD. It uses the Jinja template engine to thanks, John. We have a new user, guys. It supports a variety of input and output formats. And some other capabilities, it uses JSON LD for the templating, the basis of the templating to generate the linked data. You can generate from tabular or from XML and JSON as well. Jim has added streaming processing for extremely large files, and you can produce your RDF as a file just onto your hard drive, or upload it to an endpoint.
What streaming input are you taking?
DVOP.
Oh, okay.
Not streaming like continuous streaming, just.
Oh yeah.
But streaming like humongous files.
Yeah,
Right.
like, you have
okay.
a
Like,
very
I don't
Okay,
want
was
to
thinking
load.
real
I
streaming.
was.
Oh yeah.
It's more. I don't want to load this entire 3 gigabyte XML file into memory. at
Got
once.
it. Okay.
Yeah, sorry, it's not rate streaming.
Yeah. Right.
But
You
there's
can use it potentially.
yeah. But full support for JSON LD and all those constructs. This is sort of like the overview of the architecture. So you can see we've got a bunch of different input files that are handled in different ways. This is essentially the script. It's in a form of JSON LD, and you can run it, and it will take your input, produce RDF graphs, and then in the load step of the extract, transform, and load, you can either generate an output file or Sparkle update your endpoint.
So go back to that and dwell on it a little bit. Is the script orchestrating how the tools on the left side are being used? Is that the point?
Yeah.
Sorry.
The script. Well, so E in ETL is extract. So the libraries that you see on the left there,
Right.
those are the libraries that are used for the extract process.
Right. So these are the many different ways that you could extract.
Exactly. And so you end up using those objects in the T
Right.
So how you structure your template depends on what library you're using.
Mhm.
So IJSON works a little differently from eTree,
Right.
works a little differently from Pandas.
And then the script, the transform part, is where you also dictate how you want essentially the columns to map to your graph-based structure.
So why don't we see the S, and can go back to that picture, why don't we see the S in the picture?
It's all S.
Okay, every piece you say it has semantics.
Well, the
Yeah,
S
so
is
it's-
the overall.
Yeah,
S is the special sauce that we add throughout.
that's for special sauce.
Okay,
Well, also S is in the fact that you're dumping into an RDF graph. That's
Pretty
your,
much,
that's
yeah.
your target. Yeah.
Yeah. And like the SETLr file itself is JSON LD, so it's also semantic and it preserves provenance in that way. So it the extract and the transform and the load parts are all preserved in that way.
So that just to belabor that point just a little bit more. Go back.
Okay.
No, I'm sorry. Well, no. Well, what I'm
I'm
trying to
getting
get
like
at.
excited to like
So there's a lot of in terms of what SETLr can do. There's a lot of subtlety in looking at, for example, just because I've been battling with this in the last 72 hours, two different ways to slice and dice your XML. Okay, yeah, they're
Well,
the eTree model versus the RDF lib. There are two different
if
ways.
you want to load a RDF XML file using eTree, be my guest.
Well, no,
But
but versus pandas, which allows you a little bit more of a almost SQL-like access into your.
right, yeah, they're all the other ones are different because the tree structure, the structures that you get back are different.
Right. So the point is it's not just different arbitrary libraries. It's kind of different models that you can use for getting at it.
Yeah, exactly.
Yeah. Okay. I'm sorry. Go ahead.
All right, so this is like sort of an excerpt of some sample SETLr code. This is taken from the SETLr tutorial on the GitHub page. We did a TWed about that last March or something last year. So that's available somewhere on the Tetherless World page if you're interested in doing either the tutorials on the GitHub page, and then we've got like sort of the video walkthrough as well. But you can see that you can specify the types that you want to type different things. Like here, we're generating URL. This is an example of like a template variable where you're taking the row from the original source CSV file named ID, and you're actually just plugging that into a URI to generate it. And then you can type it as a full person. You can type your relationships, like you can create the spouse relationship and use if statements for various control flows. So for example, if you don't have a spouse for every person in your list here, it would simply skip generating this triple because it would be, oh, okay, only if it's not empty, then we generate this. But someone still has to go in and actually craft this file. So data dictionaries are already in use for like a lot of tabular data files that offer sort of like human readable lookup for expanded information on just what's in a data set. For example, in like the Jefferson project, we were using some tools, some sensors that would output data automatically, and they would give like a CSV file report of that data with numerical column headers, and you had to look up in the manual what those meant. Or in the case of like this is from the N. Haynes study, we will have like sort of a shorthand code for the name of your variable, and that's what's in your file. And the data dictionary will tell you the full expansion of that. It will often give you things like the measurement units. It might have other details like the precision of the readings, the range of the readings. This one here has the target, both males and females, 2 to 150 years. So there'll be extra information like that. And so we already have these. They're not frequently in a machine readable format. This one came from the N. Haynes webpage. So there's some HTML markup, but that's more than you get with a lot of them. For example, with the Jefferson Project tools, maybe you have a PDF of the manual with your lookup of what all those numbers mean. So we'd like to expand the data dictionaries that were given with the semantic type information and the relationships and the, and extract the entities in that way. And actually put that down into sort of an expanded semantic data dictionary in order to make it a more machine readable way, something that can explain to both the human and the computer what's going on in your data. So yeah, we have implicit entities in your data. You might be looking at your subject, since we're dealing a lot with child health and infants, neonatal health. We'll have information about the subject and the subject's mother, and they'll be in the same row. But we know that we can tell from the column names that the measurements might apply to two different people or different entities, such as like the subject versus the subject's blood sample. Or in the case of anthropometric data, the different body parts of the subject, the head, the arm, the leg, and so forth. So extracting those and adding those into the semantic data dictionary as well is important. So to take this line like from the original data dictionary, this is what it gives us. And maybe the easier task would be something like we can sort of parse over that and say, oh, in BMI, body mass index is the same thing. And we can take this out and say, okay, it's a measurement in kilograms per square meter. But a harder part would be to say, like, what is BMI? How is that calculated? Oh, it's actually a derived measurement. So if we have study A with BMI defined in this way, and we have study B that does not have this variable, but maybe that it has height and weight, is that enough to calculate the BMI even though they don't have it in an explicit column? And that's much more difficult. So we're using the semantic science integrated ontology to sort of construct like a conceptual skeleton for the data, and expanding on that to arrange the pieces, the entities and the types and the measurements and their relationships in sort of that basic structure in order to create our semantic structure for the target linked data. So this is from the SIO paper. Essentially, you have objects, qualities, measurement values. They have attributes. They participate in processes, and they have capabilities and roles. Sometimes you'll have entities located in or part of other entities. So if you have like the subject has part arm and you're measuring the arm length as part of your anthropomorphic measurement, then or anthropometric rather, those sorts of relationships. And so SIO like captures that sort of structure very well. And then the semantic data dictionary, you can go in and expand on the type and relationship information that you need to sort of round that out. So this is more examples from NHANES. You have your respondent sequence number, the body mass index, and the head circumference measurement. And these first two columns would come directly from the regular traditional data dictionary, just the human readable label with the code label. And we can also add in the information, the sequence number is an identifier. So it might be the first thing on the line, but we're not measuring a number. That's just the number that's used to uniquely identify the individual who is the subject of that row. And then we add types for the BMI, which would come from like a domain ontology or a more generic class from SIO, such as circumference. And the attribute of column tells us the entity that is an attribute of. So the sequence number and the body mass index are both related directly to the subject, whereas the subject's head circumference is a measurement specifically of the subject's head. We can also add the unit information here. So these are the unit ontology URIs.
Are we doing anything, you had part of, measurements with part of. So if the measurement for the bigger thing is smaller than the measurement for one of the parts, does anybody figure out that that's a problem?
I guess that maybe that could be something that we figure out. I mean, that could be something we could do conceivably down the line, because we would know from this and from the entity relationships here that like how it's actually constructed, and you could add in constraints conceivably like that.
But we don't do anything today.
No, not right now.
We should probably think about that if we've got these part of relationships and we're
Sure.
taking measurements of the subparts.
Yeah. We would do that.
Sorry on that.
So if you've got, like if I'm taking an arm measurement and I've measured, I don't know, wrist to elbow, and that's, I don't know,
Forearm.
16, yeah, if I've measured a forearm and somebody has a measurement of the entire arm, and the entire arm is shorter than the measurement of the forearm, something's wrong.
That is true.
Mhm.
That's,
So I was wondering whether we captured, whether we figured that out.
well, that would be a great place, great thing to put into a knowledge graph.
Right. So, if we've got measurements and we've got subpart, we should be able to figure those errors, conditions out.
Yeah. And we would do that. Like we also add these rows. These are rows that we add to the traditional data dictionary that just describe the entities, the implicit entities that we've identified in the earlier columns. So the subject and the head here. And we can give them a type. The subject is a human. This is, Uberon is a handy anatomical parts ontology. I think it actually applies to all species, including humans. So there's a lot of really weird stuff in there, but it has a concept for head. So we can use that to describe all of our different parts that we're measuring. If there's a particular role that an entity is playing, then we can explicate that here. And if it's related to another entity, we can say what that relationship is and what it's related to.
So I guess you could, Deb, you could think about, you were talking about the relationship of measurements, but you could also talk about the composition.
Yeah,
If
right.
they've got parts that they're not supposed to have,
Right,
like fins or something.
right. If humans are starting to have fins, that's pretty
Someone
interesting.
typoed
Well,
Uberon.
it's probably more likely that you would have relationships of measurements that would be in violation than that sort of thing. But you could be a typo in data entry.
Yeah, it could be a typo. I mean, what typically happens with the measurements is you've got your units off, and so all of a sudden, you weigh, you're measured in kilograms instead of pounds, and all of a sudden you have people who are like really big.
But you could be talking about superheroes or something too, and maybe that the fins are applicable.
Oh, I don't know. I don't know if we have any superhero data sets.
No.
Not that I'm aware of.
Not yet. Maybe they give us those later.
Yeah, that's right. Well, I asked Sasha about that.
Yeah, so in general, the data set columns will measure attributes of some entity. And this portion of the semantic data dictionary just tells how you can explain what those entities are and how they're related to each other. And so I've been working on automatic generation of SETLr scripts. So that sheet in the middle of the diagram earlier, generating that automatically. And that essentially, it sort of limits a little bit what you're doing with SETLr because, but it also, in that way, it also makes it easier. So essentially, we're using the SIO, we're committed to the SIO sort of conceptual vision of the data, and that's built into the script that I've been generating, or the script that I've been making that generates the script. So it's like a meta script, I guess. It limits the number of options that like a domain expert would have to fill out into a semantic data dictionary. It sort of says, all right, this is what we want the data skeleton to look like. These are the parts that we need to fill in. So this is the information that we need to complete a semantic data dictionary. And the other handy thing about this is that if you decide to make a change in your semantic data dictionary, you can change the cell in the spreadsheet of the semantic data dictionary and rerun the script, rerun the SETLr scripts, and get your new updated data. And I've been calling them Mighty Elephant, Blood Elephant scripts, with apologies to Sir Terry Pratchett, essentially because it's, we get turtle and, the SETLr script is turtle and this is the layer above the turtle. So, essentially, given a well-structured semantic data dictionary, automatically parse the contents and generate the appropriate SETLr file. And we want to do this so we can leverage the user's brains to complete the semantic data dictionary. All of the stuff that's like, well, duh, for humans, put that into the spreadsheet, and then handle sort of the often repetitive template filling for actually completing like the skeletons required to generate the RDF conversion. Take that burden off the human user and put that into the script because computers handle loops really well. And I want this to be part of a pipeline for data ingestion, essentially, between the traditional data dictionary and SETLr to help sort of make more scalable, less painful translation from essentially legacy tabular data into linked data for whatever semantic web applications you want to use. So as I was saying before, the Mighty World Elephant script contains the conceptual structure. The semantic data dictionary contains the domain-specific aspects, and like hopefully both together should work for any data set. This is sort of like the conversion pipeline. So you would be given your original data dictionary and your data files from whatever source. In my case, like HBDD with the Gates Foundation data sets. You expand the data dictionary into a semantic data dictionary by adding those extra rows. And that would then work with the Mighty World Elephant scripts to generate the SETLr file that you need in order to run SETLr and actually get your linked data ready for semantic web applications. So we have this part already, and we're given these two. And I want to fill in this corner down here to make it easier to perform the conversion. Last week at Case, I'm working on sort of a beta version of it. I've had success with an alpha version, both locally and with the Gates data that we've been working with, and I'm working on improving it. I was working with Case last week. They helped me fill out another semantic data dictionary for another page, and they did it in like a couple hours, so that was good. And yeah, so my next steps are to get the beta version working and improve documentation, see who else might want to use this sort of pipeline, my script with the SETLr scripts, and further test, I guess, from there. And also just for the Gates work specifically, start pushing data sets of concern through to see how well, how quickly we can hook it up to our front-end semantic web applications.
So what did you say that they did in a couple of hours?
They filled out a semantic data dictionary.
Okay.
Can you talk a little bit more about them? What did they actually do?
I gave them essentially a spreadsheet with the column names and the labels that we get from Gates. That was sort of copy paste from the data dictionary that was provided by the Gates Foundation, along with the extra columns that we've been using as like the template for our semantic data dictionary. And they're familiar somewhat with what we were going for since we'd had meetings with Naomi and Mohammed before. And I just sort of told them how to fill it out. I pointed them towards the unit ontology, Uberon, and the SIO and our HBGD ontology. And so they were just sort of, searching around in those on, it wasn't BioPortal, was the other one, but yeah, they were looking around for the specific units of measurement for those and the body parts.
So it's conceivable that if you had a more a data dictionary with more structure to it, it could be automatically processed.
You mean automatically filled out?
Yeah,
or?
yeah. Well, some data dictionaries, the datathon that we had this last weekend, it was a highly structured data dictionary. That you could parse if you knew what you were doing.
Well, you could definitely parse it directly into some spreadsheet form.
Yeah.
But what we really want to do is pre-populate semantic data dictionaries with suggested mappings based on background ontologies, based on string match, and actually, in fact, one of my IBM calls today was also looking at the ranges. So if you've got the data, if you see the values, which you might get from the code book, or you might actually get it from a data dump, see what the values actually are, and then say, oh, that might be this term. And then the human just goes and corrects it instead of having to fill it.
Yeah.
That's what we really want. That's what IBM wants to pay us to do.
Cool. So that's sort of a direction for future work. And also, since like I was saying, ideally this would work. You could take the data dictionary template with whatever domain ontologies you want, and my script, which contains sort of the SIO structure, which says, okay, based on the semantic data dictionary, this is how your data maps to the semantic science integrated ontologies concept of data in the linked data world. you could conceivably maybe do bidirectional data mapping if you have two separate schemata in tabular schemata or relational schemata, and maybe also do some sort of schema alignment that way.
Does it depend on style, or does it really make sense without style?
I mean, there needs to be like some way of describing, like, this is what I want the conceptual structure to look like.
That's kind of style's role.
Right.
Yeah.
So
Oh, and then
you
that
could
is
do it
style's
with
role.
another. You could do it probably. You could possibly do it with another ontology.
Yeah.
But I think that one of the underlying hypotheses here is that when you do it when you start somewhere, you gain a lot of you gain enough where it's worthwhile to assume that that's where you're starting. So the conceptual frame. So it right. So it's basically a set of assumptions or a set of it's a perspective that makes it easier to see the world in general.
Right.
And it may not be appropriate, but it's better than not knowing anything about it.
But you could have something that fit the sort of something that was served the same role, but for geosciences or something like that. And
You could, well, theoretically, SCIO could do a lot of the work for geosciences, but the question is, if you just don't like SCIO, you may not. So on the one hand, you may not like the perspective that it offers, in which case this semantic data dictionary specification, you might get annoyed with that too. But basically, a lot of the fundamental stuff in there is the same as a lot of other ontologies. So the question is, if what you want is wildly different from SCIO, then it's not going to be helpful. If it's kind of the same, then you could probably come up with a similar mapping to you. Like you can interpret these columns to your ontology somehow.
Like a case, Mohammed was asking me, if we came up with an architecture ontology and we wanted to put some architecture data into a semantic data dictionary, like what would that let us do? And so I was telling him you could reuse some things like SCIO length and SCIO circumference are probably applicable to certain aspects of architecture as well. And if you wanted to even like cross search between HPGD data and architecture data, show me all the data sets that have measurements of length and things like that.
but that doesn't count as hijacking. So
No,
when you're talking about circumference and style, it's not
It's pretty
in the
generic.
context of it's sufficiently general.
Yeah, I mean it's the length around the thing.
Yeah. And there's more, you'll get more specific things like in your domain ontologies. Like we were working with the anthropometric data, and like I didn't know before the gates, like there were so many ways to measure a baby, but there's some stuff that's very, very specific to those sorts of measurements, like the skin fold thickness and skin fold translucency. So that would be like somewhere down into like the HBDD ontology. Whereas things that like length, width, circumference, those are going to be very general. And I mean, you might have some sort of subclass relationship, like that's what you would want, is some sort of hierarchy to relate your class, your domain specific measurements to, more general ones. But
But
You might
there's
need-
length, but then there's rules for measuring that length. It's the definition.
Yeah, there's a
of that.
protocol, and also
Yeah.
like for the baby, like whether you stretch the baby, that makes a giant difference.
Yeah.
Right. Whether it's the laid down height or the standing height.
Oh, but even laying down, whether you stretch them
Yeah.
or not makes a big
Yeah.
difference. Because apparently babies stretch quite a bit. Don't break the baby.
That's what they say.
all right, so I don't know. I guess I talked too fast or something because it's only like 6:30.
Well, there ought to be more questions.
Yeah,
I tried
questions.
asking questions.
So another
Stretch the
question,
baby.
so they, how many terms were in the data dictionary about that you gave to them? And that they filled out the semantic data dictionary in a couple of hours?
Anther was one of the longer ones. I think there were maybe, I think there were maybe like 50 or 60, but some of them are like, there were some that were like, it's like measurement at birth and measurement at like 39 and a half weeks.
I was
things
just
like
trying to
that.
extrapolate, but even
Yeah.
though there's more there, I think it's an easier set of terms.
Yeah.
Most people kind of know what length and
Mhm.
upper arm and things are.
Yeah. And although there were some things where we're like, what? But fortunately, there's Wikipedia.
And when you gave them data dictionaries, this is open content, so it's collaborative perinatal project CPP data, or
This was the HBGD data spec. But it's general. It's not any specific data set. It's the data specification for anthropometric measurement. So there's no data involved yet.
okay,
They reuse the same one.
okay.
Yeah.
But is that okay? Like, do we have that on a server? And if so, is that okay to have on a server, or is that
It is.
considered?
Yeah, I have it in like a private Google Doc that we just like worked on together. So like the subject one that I've been working on. But yeah, so it's like this many data dictionaries is a spreadsheet. You can fill it out with your friends and coworkers.
Good time.
Yeah, we had a blast. Any other questions?
Any general SETLr questions?
Oh, there's one other thing that I forgot to mention on the list of new SETLr features, and one of which is that we now support Beautiful Soup. So you can load a HTML document tree and then scrape it using the Beautiful Soup API into SETLr. For those of you who are familiar with that, enjoy using it.
So what projects are you using SETLr?
HBGD.
HBGD, Namine, Cheer,
DARPA, the DARPA additive manufacturing.
Sub next. You're using the sub next too.
Yeah, to do some of the knowledge graph update stuff, which isn't working right now. But it's nothing wrong with the tool. The tool's great.
You're trying to use SETLr.
What about data one?
No, actually, we're not using SETLr for that.
Well, I don't know that we're ingesting any new content.
Yeah, there's no call for it really. I mean, I guess I could use it when I'm doing so we have data set metadata that we get, and I guess I can use SETLr to generate the ontology. Right now I just have code doing that. That might be a good place. That might be a good thing to do with it actually. We'll see. We don't have much funding left on it anyway.
What about for units? So are we using, like, I think, yeah, so we've got, what, 7 different units, ontologies?
Yes, you will be once it gets it. No, once you've kind of developed the combined knowledge graph, right?
So is this
Yeah, so you can use SETLr to take, you can transform existing RDF graphs into new RDF graphs, or take other data resources and transform those into like that.
So it's like end-to-end.
It's a tool you can use
Go
to,
back to the SETLr.
yeah.
Oh, yeah.
I
This
use
one
it.
or?
No, we only spent 5 hours on it.
Yeah, that's right. Thanks to John.
So basically, you can transform various kinds of data into into whatever kind of RDF you like. It uses a templating system inside.
So I was talking to Paolo about, so he doesn't want JSON-LD, he wants CSV, but compliant with the schema. So what's it going to take for you to dump something compliant with somebody else's schema?
Well, you could run a Sparkle query on the resulting graph. I mean, that would be the most like guaranteed right answer for that. But I think that so it may be overkill for what he's
What does
doing.
that mean? Does that mean he?
Yeah, but
He needs to load it into How to Tack. He needs to be compliant with the hot attack schema. And the
So, but
input
what-
format is CSV, but
Well-
CSV compliant with his schema.
I guess I still don't know what that means. So heart attack is a big knowledge graph, right? It's a
Yeah, it's a big knowledge graph.
it's a graph, okay?
Yep.
There's
And there's all these
CSVs
tables, and
coming,
all those
well,
tables have
CSVs
schemas.
come into it.
Yeah.
But what's the compliance? Is the compliance what gets pulled out of it? So if
So all of those tables have schemas.
yeah,
So he expects a CSV to be compliant with some schema.
so you're saying, so it's a question of verifying that these are compliant before loading it in? I'm wondering why, if they're coming to him, why he cares.
Someone's got to map it to his schema.
So they gotta map
A CSV to a different CSV.
what, so, well, yeah, when
We had a
I,
conversation.
No, yeah,
I
so
had
I-
that conversation.
Yeah, well, so actually, so he's less concerned about the CSVs, at least he was this morning.
Okay.
And it's more about mapping it to a,
should I, are we done? Should I
Yeah,
cut
we're
this
probably
here?
done.
Okay.
Thank you, everybody.
Bye.
by
Okay.